This is Dr. Mohan Lakshmi, Professor and Head Department of Electronics and Communication Engineering from Rohini College of Engineering and Technology, Kanyakumari District. So in this lecture, we'll see about the Zener diode and how it is acting as a voltage regulator. So on completion, the student will be able to describe the function and characteristics of a Zener diode. They will be able to schematically represent the symbol of a diode, this diode, and they will be able to explain how this Zener diode can act as a voltage regulator. So Zener diode, otherwise it is called as a regulator, it is used to maintain a fixed voltage. So they are designed to break down in a reliable and non-destructive way so that they can be used in the reverse to maintain a fixed voltage across the terminals. So the diagram here shows how they are connected with the resistor in series to limit the current. So you could see here a Zener diode, which it will be having a fixed output voltage. Some input voltage is given, so there is some resistor to limit the current. So the voltage is kept constant, whereas during the breakdown voltage it is kept constant, whereas the current keeps increasing. A Zener diode is a special kind of diode which permits current to flow in the forward direction as normal, but will also allow it to flow in the reverse direction. When the voltage is above a certain value, the breakdown voltage occurs, which we call it as a Zener voltage. So commonly available Zener diodes are available with the breakdown voltages anywhere from between 1.8 to 200 volts. So what is the history of Zener? So this is named after Clarence Melvin Zener, who discovered the Zener effect. So Zener reverse breakdown is due to electron quantum tunneling caused by high strength electric field. So this shows you the VI characteristics. You can see at the leftmost side the symbol. Here you can see a cathode and the anode. That is the symbol, and this is almost similar to the PN junction diode in the forward region, whereas in the reverse bias or in the reverse region, so there will be a Zener breakdown region, so where there will be a constant Zener voltage. You could see a minimum current and a maximum current, which is a reverse current, whereas in the forward bias region, which is very normal operation with the voltage, that is your PN junction diode. So the forward voltage it is given by 0.3 to 0.7 volt, whereas this Zener voltage, it depends upon the breakdown voltages, Zener voltages. So this is the VI characteristics, and the illustration above which we have shown is a current versus voltage graph. So with the Zener diode connected in the forward direction, it behaves exactly the same as a standard diode. That is, there will be a small voltage drop of 0.3 to 0.7 volt with current flowing through pretty much unrestricted. So of course we know that in the forward bias there will not be any restriction in the flow of current. In the reverse direction, however, there will be a small leakage current between 0 volt and the Zener voltage. That is, this is a very small amount of current which could be able to flow. Then when the voltage reaches the breakdown voltage, say it is represented as VZ, suddenly the current can flow freely through it. So you could see that the current flows freely through it. So the Zener voltage of a standard diode is high, but if a reverse current above that value was allowed to pass through it, the diode is permanently damaged. So Zener diodes are designed so that their Zener voltage is much lower. For example, say 2.4 volt. When a reverse current above this Zener voltage passes through this diode, there is a controlled breakdown which does not damage the diode. The voltage drop across the Zener diode is equal to the Zener voltage of that diode, no matter how high the reverse bias voltage is above the Zener voltage. So Zener diodes can be distinguished from ordinary diodes by their code and breakdown voltage, which are printed on them. You could see on the diode there will be certain codes like which will begin with VZX or VZY, and their breakdown voltage will be printed with V in place of decimal point. Say for example it is a 4V7, it means 4.7 volt for example. So Zener diodes are rated by their breakdown voltage and maximum power. The minimum voltage available is 2.4 volt. Power ratings are which ranges between 400 milliwatt and 1.3 watt are common. So this is the circuit symbol. You could see this is a physical identification. It is mentioned here. You can see 447. It is actually 4.7 volt. So in the other diagram, you could see here BZX4B7. So this is the circuit symbol, and you could see in the cathode representation, it is in the form of a Z. That's how we have to represent. Whereas in the PN junction diode, we have to put a very normal straight line. Whereas in here, you have to represent with an Z. And where do we really use this Zener diode? As this voltage dropped across the Zener diode is known, and it is a fixed value. They are typically used to regulate the voltage in electric circuits. That's why the Zener diode will act, or it can be used as a voltage regulator. So using a resistor to ensure that the current passing through the Zener diode is at least 5 milliamps. The circuit designer knows that the voltage drop across the diode is exactly equal to the Zener voltage of the diode. So applications, it can be found in several applications. Some of these are listed here. Voltage stabilizers or regulators, preferably in the shunt mode, that is in the parallel mode. Surge suppressors for device protection. Peak clippers, switching operations, reference element, and in meter protection applications. The constant reverse voltage of a Zener diode renders it a very useful component in regulating the output voltage against variations in the load resistance or variations in the input voltage from an unregulated power supply. So I think you are able to say what is Zener voltage and how this Zener diode will act as a voltage regulator, and you could also able to list the applications of a Zener diode. Thank you.